Hi class. In this video here we want to move into section 2.6 and this is talking about marginals. We're going to look at marginal analysis. This is like an economics term, and what a marginal analysis means is, one extra unit. So when you do things, when you're going to look at if you're going to produce, sell, and how much profit you're going to make from selling just one additional unit. So here what we're going to look at is we're going to look at marginal cost, marginal revenue, and marginal profit. Okay, so marginal here is the concept of one additional unit. So the idea with marginal cost, marginal revenue, and profit here, and the calculus aspect of it, is what we're going to be investigating is the rate of change of, again, selling, producing, selling, revenue, and profit for one additional unit. And when you think about rate of change, what are you thinking about? You're thinking about a slope. So for here, that's going to be our derivative. So that's where the calculus comes in. Okay, that's how we're going to use calculus here. And all I want to do in this video here is I just want to walk you really through just two examples. So two word problems, and then what we'll do is you'll be ready to tackle your homework here. So the word problems in your homework and everything are just going to follow kind of basically these two examples here. All right, so let's first officially define the marginal what marginal cost, marginal revenue, marginal profit is. So we're going to let C of x, R of x, and P of x represent respectively the total cost, total revenue, and total profit from the production and sale of x items. So you're going to make x items and you're going to sell x items. So the marginal cost at x, okay, so the marginal cost at x. Now here's the thing, and before I continue, a lot of people are like, well, doesn't it just cost the same? Every item you produce costs the same amount. It's not necessarily the case, right? Like if you think about manufacturing process, they got to build a factory, set up an assembly line. If they're going to do all that to make one item, it's going to be really expensive to do that, right? And then, but if the next item they make is going to be a little bit cheaper because they're already going to have all this material and stuff set up. So marginal costs, it could go down. It's not always constant, okay? And it really depends on how your cost function is defined. If your cost function is linear, then yes, the marginal cost is constant. But if not, then that's where the more interesting analysis comes in. All right, so the marginal cost at some value x, so at selling and producing x unit, is given by c prime of x. So it's the first derivative. Okay, and this is the approximate cost of producing the x plus 1 item. So another way you could look at the first derivative is the rate of change here. The marginal cost of producing that x item, you would take the cost to produce the x plus 1 item minus the cost of producing x items. Okay. Another way you could do it, the cost of producing, the x plus 1 item is the cost of producing the x item plus the marginal cost to produce that x item. That's another way you could do this. So but for our analysis for this class, just marginal cost, first derivative of the cost function. And then it follows the same. Marginal revenue is given by r prime of x, so it's the first derivative of the revenue function. All right, and then the same thing here. The marginal profit, p prime of x, is the approximate profit. So the marginal revenue here, is the approximate revenue from the x plus 1 item, and the marginal profit here, p prime of x, is the approximate profit for the x plus 1th item. So it's really just the first derivative. Okay. So what I'm going to do is I'm going to break this lecture up into two videos. So this first example here is going to be, I'm just going to give you the cost function and the revenue function, and then I'll follow this up with a little bit more business, a little bit more context behind it example. Okay, so for this first example here, c of x is equal to 62x squared plus 27,500, and that's cost function and the revenue function of selling x items. The revenue you bring in is equal to x cubed minus 12x squared plus 40x plus 10. Okay, so let's find each of the following. Let's find the total profit, P of X, and just, what is profit? Profit is revenue minus cost. Then let's find the total cost, total revenue, and total profit from the production and sale of 50 units. Okay, so if you're going to sell 50 units. And then let's find the marginal cost, marginal revenue, and marginal profit. All right, when 50 units are produced, okay? And I'll explain, the context of the marginal cost and marginal revenue, marginal profit in that case for you so you can understand exactly what's going on. Okay, so let's jump. Let's start with the total profit. So the total profit is equal to the total revenue minus the total cost. Okay, so we're going to denote our profit function P of X, and that's equal to the revenue function minus the cost function. Very, very easy. Well, we had our revenue function that was x cubed minus 12x squared plus 40x plus 10, and then you're going to minus the cost function was 62x squared plus 27,500. All right, so just cleaning this up, right, the x cubed stays. Minus 12x squared minus 62x squared gets you minus 74x squared plus 40x. Okay, and then 10 minus 27,500 is minus 27,490. Okay, so that's our profit function right here. So next it says let's find the total cost, total revenue, and total profit, okay, from producing 50 units. Okay, so remember here we're going to do 50 units. So we get total costs. That's just the cost function evaluated with 50. So that's going to be 62 times 50, just plugging in the value 50 in for x here. So if you plug it into the cost function, I'll just save us some time. It's 182,500. It's expensive. The total revenue they're going to bring in, well, that's the revenue function evaluated at 50. So going back, what's our revenue function? It's this, so I'm going to plug 50 in for this, just how I plugged 50 into the cost function here. So it's 50 cubed minus 12 times 50 squared plus 40 times 50 plus 10, and it looks like they'll bring in $97,010, just working this out a little bit. What is the total profit they make? Well, if you look here, they're going to lose money, right? But let's even just plug it into this profit function we have here. You could just subtract these two numbers. You'd go this minus this. But if you plug it into the profit function we have, it's 50 cubed minus 74 times 50 squared plus 40 times 50 minus 27,490, and it looks like they were going to lose $85,490. Not good. Not good. Sorry, that was part B. Okay. So we've got total profit, we've got the total cost. Now let's talk about the marginal cost. Okay, so when you're going to have when 50 units are produced and sold. Okay, so what these marginal costs are going to tell us, if we're at 50 units, what is the marginal cost is going to tell us the cost to produce the 51st unit. Okay, the marginal revenue will tell us the additional revenue we'll bring in from selling the 51st unit, and the marginal profit will tell us the amount of profit we'll bring in from selling the 51st unit. Okay, so marginal cost is just C prime of x. So you're going to take the derivative of your cost function here. So the derivative of the cost function, you just bring the 2 down, right? So it ends up being 62 times 2, which ends up just being 124x. So the marginal cost at 50, you're just going to plug 50 in. And it looks like it's, if you do 124 times 50, it looks like it's $6,200. So that means it costs to produce the 51st unit. Yikes. Okay. So now let's do marginal revenue. That's R prime of X. So you're going to go back. You have to take the derivative of the revenue function here. So that's easy, right? It's 3x squared minus 24x plus 40. Okay. So the marginal revenue at 50 units, you're just going to plug 50 into here. And when you do, you end up getting, it looks like $6,340. So the additional revenue of this 51st unit is 6,340. Okay, and look, you can see the marginal profit. You could just subtract, and you'll get 140. But let's actually do it with the function. So the marginal profit is the first derivative of the profit function. So going back here, what you're going to do is you're going to take the first derivative of this. So it's going to be 3x squared minus 148x plus 40. So the profit function at 50 is equal to, so we're going to plug in 50 here. And when you do, you end up just getting the difference of these two. You end up, if you just plug in your calculator, you get 140. So what we're seeing here is the additional revenue of this 51st unit is $140. So it's positive revenue coming in. All right, so what I'll do is I'll follow this video up, this lecture here, with another example just to break it up a little bit for you.